So I want you to put yourself in a really specific scenario for a second. Um, Imagine you're looking at a country that is grappling with two massive crises.
Right, and crises that seem, completely unrelated at first glance.
Exactly. I
Yeah.
mean, on one hand, you have this severe youth unemployment problem, specifically in rural areas where young people are just leaving in droves.
Yeah.
And on the other hand, the national food supply chain is dangerously fragile.
Super fragile, like relying heavily on foreign labor and vulnerable to just the slightest disruption in global trade.
Right. And if you were tasked with solving both of those systemic problems at the same time, your first instinct might be, I don't know, a massive infrastructure bill.
Or maybe like sweeping agricultural subsidies, something like that?
Yeah, but the sources we're diving into today propose something entirely different. They suggest the solution is basically a heavily engineered metal box, an interface that feels like a high-end management video game, and this is the wild part, a completely new type of university degree.
Which, framing it that way really highlights just how unconventional this approach is. But when you look at the actual architecture of the initiative, it's an incredibly pragmatic strategy.
It really is.
The goal isn't just to modernize farming, it's to fundamentally rewrite the socioeconomic reality of an entire demographic.
And that is exactly what we are unpacking in today's deep dive. We have a pretty dense stack of materials to get through today.
Oh yeah, very dense.
We've got a high-level system architecture blueprint for a smart farming system, a super strict technical context packet detailing all the hardware, and a comprehensive socioeconomic white paper outlining this new educational paradigm.
And our mission today is basically to synthesize how this ambitious initiative in Malaysia is fusing automated container farming, a dual-study university degree, and $0 financing to just completely revolutionize their agricultural sector.
Right. But to really grasp the scale of this intervention, we first have to kind of understand the paradigm shift they're attempting here.
Yeah, because globally, but particularly in Malaysia, agriculture has long been associated with grueling manual labor.
Right. Low wages, lack of social mobility.
Exactly. So this initiative is attempting to completely rebrand the sector. They're reclassifying the work as high-technology operations to attract a demographic that desperately needs a foothold in the modern economy.
And the socioeconomic white paper refers to this specific demographic as the lost generation.
Which is a heavy term.
It is.
Yeah.
We're talking about underemployed youth within what Malaysia categorizes as the B40 demographic.
Right, the bottom 40% of income earners.
Exactly. And when you read through the field interviews in the white paper, the sentiment is overwhelmingly clear. I mean, if you're a 20-year-old living in a rural municipality, traditional farming just looks like a dead end.
Yeah, you're looking at a lifetime of physical toil with basically zero financial security.
So the natural consequence of that perception is the rural brain drain. Young people pack up and move to urban centers like Kuala Lumpur.
Chasing service sector jobs or maybe entry-level tech positions. They want prestige and stability, which traditional agriculture simply does not offer.
But that urban migration creates a really dangerous vacuum back home. With the younger generation abandoning the fields, the national food supply becomes critically vulnerable.
Yeah, the country is forced to import foreign labor just to maintain baseline food production. It creates this huge structural weakness that threatens national stability whenever borders close or supply chains bottleneck.
This is where the structural educational intervention comes into play, because the developers of this initiative recognize that you can't just, launch a flashy ad campaign telling young people to go back to the fields.
No, that never works. You have to offer them a genuinely prestigious, highly technical career trajectory.
Which brings us to the Agro-Technician semi-degree path. And the sources emphasize that this is not some generic online certificate you knock out in a weekend.
Right. It's a formal academic program aligned directly with Malaysia's national TVET policy 2030.
Which stands for Technical and Vocational Education and Training, right?
Exactly. And to ensure the program actually carries weight, it was developed in direct collaboration with Taylor's University, which is a leading institution based in Sunway, KL.
And that collaboration with Taylor's University seems like the linchpin of the entire educational strategy.
Oh, absolutely. They're utilizing a dual study model. It's heavily inspired by the successful vocational pathways you see in countries like Germany or Switzerland.
Okay, so it's built on two very distinct pillars to bridge the gap between academic theory and industrial application.
Right. The first being the academic pillar. Taylor's University provides the rigorous theoretical foundation. So the students aren't just like learning how to plant seeds.
They're studying advanced bioscience, the intricacies of complex crop cycles, and digital economy frameworks.
Yeah, they're learning the actual underlying biological and economic science.
And then you have the vocational pillar, which is the practical apprenticeship part of it. But the crucial distinction here is the environment.
Yes. The classroom for this vocational training is not a dirt field. It is inside a piece of hardware called the Agro-Shack.
The Agro-Shack, which acts as this highly localized laboratory. Reading through the syllabus requirements, it feels akin to a medical residency, but for high-tech agriculture.
That's a great analogy, actually, because inside this environment, students have to master the hardware and software protocols that serve as the actual life support systems for the biology.
Right. They learn network compute management, how to troubleshoot industrial sensors, how to route complex utility topologies.
And by the time they complete this semi-degree, the white paper formally classifies them as certified agrotech masters. Yeah. They're essentially high-tech systems engineers specializing in biological assets. And mastering these protocols provides what the white paper calls human capital ROI.
Meaning it restores dignity and technological relevance to the profession itself.
Exactly.
But to really understand why you would need a university-level semi-degree just to operate a farm, we gotta have to look closely at the machine they're operating.
Oh, we have to. Because when people hear container farm, they usually picture a rusty shipping container retrofitted with some basic LED lights and a few water pumps.
Yeah, like a DIY project. But the blueprint we have paints a vastly more complex picture. I was completely deking out over the physical infrastructure.
It's intense. So the physical foundation of the Agro-Shack is a standard 40-foot high-cube container chassis.
And that specific dimension is chosen because it's inherently optimized for flat pack international logistics, right?
Right.
So they can rapidly deploy these anywhere in the world.
Correct. But that chassis is just the metallic skeleton. The operational core is the localized edge computing system known as the SAIN.
The Smart Agro Intelligence node, let's really dig into that because the technical packet specifically emphasizes edge computing over cloud computing.
Right.
And at first glance, you might wonder why they don't just run the telemetry through the cloud like the way a smart home thermostat works.
Well, when you factor in the realities of rural infrastructure, cloud dependency becomes a massive liability.
Because in a mission-critical agricultural environment, system downtime basically translates directly to biological death.
Exactly. Think about it. If a rural agro-shack relies on a central cloud server to dictate its water and nutrient cycles, and a local storm knocks out the internet connection for 12 hours.
The entire harvest is just lost.
Right. So by localizing the compute resources through the SAIN, the system achieves this incredibly high availability responsiveness. The node processes telemetry and regulates the environment independently,
ensuring the crops survive, even if external communications go completely dark.
Yeah.
But there is a glaring physical contradiction here that jumped out at me. You're taking high-density computer servers and putting them inside a metal box alongside thousands of gallons of water, high-humidity irrigation systems, and biological matter.
Yeah, it sounds like a recipe for a short circuit.
Right. The potential for catastrophic failure seems incredibly high. Like, a single burst pipe could theoretically destroy both the crop and the localized server.
Well, the engineering team anticipated that exact vulnerability. Their solution relies on intense physical and logical isolation.
Okay, break that down for me.
So this SIN architecture doesn't rely on a single server. It utilizes dual Proxmox HA high availability server nodes.
The virtualization platform.
Correct. But they do not place these servers right next to each other. The blueprint actually specifies that these dual nodes are housed in physically isolated IP65 and IP66 water-resistant partitions.
And they place them at opposite ends of the core chassis.
At the absolute opposite ends of the 12-meter container.
So they're maximizing the physical distance between the redundant systems. Meaning if a tractor backs into the left side of the container or a major waterline ruptures on that end, the IP66 enclosure buys them a few critical moments.
Exactly. And in those moments, the logical isolation takes over. Because the servers are virtualized across that physical distance, the redundant node on the undamaged right side instantly assumes the compute load.
It migrates all the automation tasks seamlessly.
Yeah, ensuring the environmental controls do not experience a single second of downtime.
Okay, so the intelligence is secure. But a brain is totally useless without a nervous system to feed it data.
Right, it needs sensory input.
And the technical packet outlines a multi-protocol sensor registry to handle this, and it leans heavily on an RS-485 Modbus RTU backplane.
Yeah, and for anyone unfamiliar with industrial networking, it's worth exploring why they chose this specific protocol over something simpler, like standard Wi-Fi.
Because the physical environment inside the AgroShack kind of dictates the networking choices, right?
Completely. You have a metal box filled with high-voltage lighting ballasts and heavy-duty water pumps. All that equipment generates a massive amount of electromagnetic interference.
Which would easily scramble standard wireless signal.
Oh, absolutely. So they use a hardwired serial bus.
And the packet specifies shielded twisted pair cabling. So the shielding physically blocks that electromagnetic noise, ensuring the telemetry data never drops.
And the data they're pulling is exhaustive. The RS-485 network tracks soil EC, which is electrical conductivity, and real-time NPK levels.
Representing the nitrogen, phosphorus, and potassium the plants are currently absorbing.
Right. It also integrates subfloor leak detection sensors calibrated to monitor the integrity of the chassis base.
Wow.
And all of this mission-critical, hardwired data flows directly back to those isolated sane cores.
But for secondary data stuff that isn't strictly life or death, they do utilize wireless protocols, right?
Yeah, a localized Zigbee mesh network handles internal ambient data, so things like canopy temperature, humidity, and door-open microswitches.
And for data leaving the box, they use a LoRaWAN wireless star topology. This handles long-range external telemetry, like perimeter security and outside weather conditions.
Transmitting back to a gateway mounted on the exterior of the chassis?
Which naturally brings us to the exterior architecture.
Yeah.
Because deploying these units in Malaysia introduces a really severe environmental challenge.
Oh, yeah, the thermal load.
Right. I mean, a 40-foot steel container sitting under the tropical sun is essentially just a solar oven. All the edge computing in the world cannot save a crop if the ambient temperature inside the box reaches 50 degrees Celsius.
Exactly. And the thermal mitigation is arguably the most impressive physical engineering in the entire blueprint. They utilize a system called stack effect cooling architecture.
Okay, how did that work?
Well, the first element of this is the foundation. The AgroShacks are not placed flat on the ground. They are elevated exactly 1 meter into the air using specialized earth screw drive foundations.
So they're driving metal piles directly into the soil instead of pouring concrete.
Yeah, which allows for rapid modular deployment without permanently scarring the land. But that 1 meter elevation serves a dual purpose. It isolates the chassis from ground moisture and flooding, but crucially, it creates a reservoir of shaded, cooler air underneath the structure.
Okay, that makes sense. And the walls of the container themselves are heavily insulated with core polyurethane or PU sandwich panels.
Right, but insulation alone merely delays the transfer of solar heat, It doesn't actually stop it. The real brilliance of the stack effect lies in the exterior cladding.
The bamboo, right.
Yes. They install my bamboo paneling, but they enforce a strict offset distance from the core PU panels.
So they intentionally leave an air gap between the bamboo exterior and the insulated steel wall. That operates very much like a heat sink on a computer motherboard or those double-skin facades you see in modern desert architecture.
Exactly. As the tropical sun superheats that outer bamboo layer, the air trapped in that gap rapidly warms up, and because hot air rises, it creates an updraft.
Oh, wow.
Yeah, it continuously pulls the cooler, shaded air from underneath the elevated container. It basically becomes a passive thermodynamic engine that constantly dissipates massive amounts of solar radiation before it can even touch the core insulation.
That is brilliant. It drastically reduces the thermal load on the internal air conditioning systems, which obviously saves immense amounts of electricity.
And the socioeconomic white paper also points out a psychological and security benefit to this design.
Oh, right, because the My Bamboo cladding visually obfuscates the container.
Yeah, it blends the structure into the traditional rural aesthetic. It completely hides the fact that there's a highly expensive automated server farm humming inside, which deters petty theft.
The engineering is undeniably sophisticated, but, and there's always a but, that sophistication comes with a really steep financial reality.
It does. And this is where the entire initiative faces its greatest stress test.
Because the blueprints detail 3 configurations, small, medium, and large. And the large configuration utilizes dual-side hinged extensions. So the walls literally fold out to expand the internal volume,
Creating something like 850 square feet of cultivation space, which delivers a 3.5 times yield multiplier.
It's a massive footprint. But the white paper explicitly states that the capital expenditure for this large commercial configuration reaches up to RM 500,000.
500,000 ringgit.
Right. So think about the target demographic we discussed earlier. You are trying to recruit a 20-year-old from the B40 income bracket.
A youth who likely has zero collateral, no credit history, and very limited savings.
Exactly. If you tell them the entry fee to this new high-tech career is RM 500,000, the initiative just fails before it even begins.
Yeah, the developers understood that technological innovation is basically meaningless without financial accessibility. So to solve this, the initiative relies on an SPV, a special purpose vehicle, that essentially re-engineers the financial risk completely.
Okay, looking at the breakdown of the SPV, it operates as a massive, multi-tiered collaborative ecosystem.
Right. You have Ecoladang microfarms acting as the technology provider. They hold the IP and the chassis designs.
You have My Bamboo supplying the sustainable thermal cladding. Taylor's University drives the academic research and yield optimization.
But the structural pillars making this actually financially viable are the SADC, the State Agricultural Development Corporation, and the QOP Bank.
Because these state-backed entities serve as the financial facilitators.
Exactly. The SPV architecture provides two very distinct financial logic paths. And this logic is so foundational that it's coded directly into the digital twin software they use to configure the farm layouts.
Wow.
Yeah. The first path is the tiered franchise model.
And this path operates more like traditional private equity, right?
Yeah. If a private investor or commercial entity wants to scale a farming operation, they pay a licensing fee. It starts at RM 100K for an entry-level small unit, scales to RM 200K for a medium, and tops out at RM 500K for the large multi-site commercial operation.
So this pathway injects vital private capital into the broader ecosystem.
Exactly. But the second path is the KEOP model, and this is engineered exclusively for Malay collectives, smallholders, and the B40 youth demographic we've been talking about.
And under the KOP model, the upfront license fee is RM 0.
$0.
A $0 entry barrier for a $500,000 asset. I mean, the immediate question is just how the SPV sustains that. The steel, the Proxmox servers, the RS-485 cabling, none of that is free to manufacture.
No, it's not. The cost is absorbed by the state through a highly specific mechanism. The RM0 entry is entirely subsidized and funneled through specialized co-op bank loans, which are heavily supported by SADC grants.
So the state is willing to absorb this initial capital risk because the overarching objective of the COPO-Pay path is not private profit.
Right. The goal is community food sovereignty. It's fulfilling a state mandate to economically elevate vulnerable rural populations.
So the state evaluates the landscape and determines that they desperately need a resilient food supply, and they desperately need their youth to be employed in productive sectors.
Exactly. So they guarantee the financing, they provide the grants for the infrastructure, and they task the SPV with providing the technology and the education.
And this specific dynamic introduces the final, really crucial component of the white paper, the state-approved integrator model.
Yes. And the text specifically references the Sultan of Perak's Food Basket Initiative as the template for how this works in practice.
Under the integrator model, the state basically stops viewing these farms as isolated private businesses and starts treating them like deployable public utilities.
Right, no different than a water treatment facility or a municipal power substation.
Right, so Ecoladang steps in as the integrator. They deploy the flat-packed modular infrastructure, and they provide the standardized biological assets, whether that's specialized mushroom spawn or high-yield poultry chicks.
And the local youth, our certified agro-tech master, takes control of the node. And because they're operating within a closed-loop system governed by the CIAN, the quality and output of the harvest are highly predictable.
Meaning the integrator can guarantee market pickup.
Exactly. The young operator does not have to worry about marketing their crop or finding a buyer. The state supply chain just absorbs the harvest and pays the operator a guaranteed fee.
Which is huge. By standardizing the biological input and guaranteeing the market output, the state systematically removes the economic volatility that typically ruins small farmers.
Yeah, the youth receives a high-tech, respected career path without crushing debt. And the state secures a decentralized, solar-backed food production network that's basically insulated from global supply chain shocks.
It creates a structural permanence that completely reverses the rural brain drain. You no longer have to move to a crowded urban center to participate in the high-tech economy.
No, you can remain in your local municipality, manage a highly automated agro-tech node, hold a respected university certification, and serve as the backbone of your country's food security.
It takes an industry defined by manual labor and translates it into digital systems management. I mean, the sources even describe the software UI as an agro-excitement interface.
Yeah, they intentionally gamified the controls so that operating the farm feels like playing a simulation. It removes the intimidation factor of all that complex hardware.
So when you combine the physical isolation of the salmon, the thermal mitigation of the stack effect, and the financial de-risking of the SPV, you're looking at a blueprint that fundamentally alters how a society interacts with its basic needs.
It's incredible.
Which leaves you with a deeply provocative thought to consider. If this model actually succeeds, if a nation can successfully gamify agriculture, provide $0 financing via state SPVs, and use dual study degrees to turn farming into localized data center management, what happened to the rest of the economy?
Oh, man.
Right. Consider other industries heavily reliant on physical toil. Could we see this exact same SPV and edge computing framework applied to construction?
Or mining or waste management.
Exactly. If you can digitize the farm, de-risk the capital, and rebrand the labor, this might just be the ultimate blueprint for the future of all physical work. Something to mull over as you look at the systems operating around you. Thank you for joining us on this deep dive, and see you next time.